Hello everyone! The goal of this video is to show you that running Llama 405 billion parameters model on Runpod is easy, but also how costly it can get if you don't know some things in advance. And I hope that this video will help you to save these GPU precious minutes. So first of all, Llama model 405 billion is huge one, and it requires around 800 gigabytes of memory. So you need pretty powerful GPUs for this. And let's talk about GPUs. There are some very good options like H100, 800, and H200. And in this table, you can see how they differ from each other. So for Llama model specifically, H200 SXM is the winner one because you need fewer GPUs with this one because the VRAM memory is higher. It's 141 compared to 80 gigabytes for H100, for example. But also with a lower price, you'll get 3x around higher inference time. And when it comes to providers, there are very good options out there like Runpod or FastAPI or Lambda, and sites like this one, for example, can help you to browse different options and compare pricing. But I preferred for my recent experiment to use Runpod because it's very easy to set up, easy to work with, has a nice interface, but also has competitive pricing, and GPUs are always available, the ones that I needed for my experiment. And just to give you a taste of what cost might be for Llama 405B model is if you choose H200 GPU, and you need 5 of these, you'll pay around $18 per hour. And when you stop the Runpod, you'll need to pay for storage in case you want to retain the data, and this will be around $3 per day. I want to share with you 4 tips that I believe will help you to save your money when working with big models. And first is that preparation is a key. So first, you need to prepare your code, test it locally. And also it's a good idea to prepare like a setup that you will run. You'll first SCP to Runpod because it contains some sensitive data, so please don't push it to GitHub. So an example of this, you can use the script that I created. So this is where I set up my Git credentials and some API keys, uninstall different packages that I need, like Poetry, for example. And then once I package the code and push it to GitHub, there is also another script that you would need to prepare your environment and install the package. So this might look like this. And yeah, you'll just need to run it on Runpod and prepare your whole environments. But also before actually going and running your codes on a big model, I recommend you to first find the smallest possible model in this family. For example, Llama has Llama 1B models that I could run locally, but also I first spinned up CPU pods and tested all my code there. And yeah, it required some fixing and debugging, but yeah, it was much cheaper than starting immediately with a large model. So tip number 2, you need to know the difference between root and workspace directory. So I recommend you to store your codes on the root directory because it's fast for reading and writing operations, but store all your data, cache, model parameters, everything like experiment outputs under workspace because it's permanent, and you can stop Runpod and then run it, spin it up again, restart it actually, and then your data is still under workspace. To do this, you need to direct all your, for example, if you use Poetry, then you need to direct your Poetry and Torch and Hugging Face cache directly to workspace, and this is how you do it. Tip number 3, network volume is your friend. So what is network volume? When you store your model parameters, experiment outputs under workspace, it's still there, but there is no guarantee that you will be able to restart the pod with the same GPU pods, because they might just simply be not available. And then when you want to restart your pod and GPUs are not available, what happened to me, then your pod just gets downgraded to 0 GPU pod, so you can't really do anything except just, go in and maybe downloading data. But you also need to know that downloading Llama model is quite expensive, and on average it takes around 30 minutes to download it. So you don't want to waste your half of an hour to download the model every time you start the Runpod. So this is where the network volume comes in. And which is what's good about it is that it offers persistent storage that exists independently of your compute resources, meaning that you can terminate your pod and your data is still there on the network volume. You can create like a new Runpod with a new, like another GPUs, another configuration, or CPU only pod, and then mount network volume onto workspace directory. And it's also very fast for data transition, and it's quite cheap. But also you need to make sure, let me show you that it's very easy to create it. So you go to storage on Runpod, you go to new network volume, and this is where you need to choose your data center wisely, because you need to make sure that you have GPUs that you're intending to use, like H100, and preferably multiple types of them, because they might not be always available. Tip number 4 is you need to optimize on the model loading. And there are actually 2 flags that you should take care of when you load the model. You need to set low CPU mem usage to true, and despite its name, it also helps with the GPU utilization. So without this flag, what happens that program tries to load all the weights, all the tensors at once, and sometimes you can get the peak of memory like 2 or 3 times the model size. And when it's on, when this flag is set to true, then the program loads weights 1 tensor at a time and immediately assigns tensor to a layer and then frees up the memory and continues with the next one. So you'll always stay within the range of the model size when loading the model. And second one, if you're planning to run multiple experiments on the same model, then I recommend you to separate the codes for model loading and serving and experimental code. And for example, use FastAPI to wrap the model into service and create API endpoints like for inference, like generating output or doing interpretability, things like activation, layer patching or intervention, etc. And then keep your experimental code separately, because it also keeps changing. You need to make some modifications, push the code to GitHub, and you don't want to restart the model on every change of experimental code. And yeah, that's it. And of course, don't forget to stop your Runpods, and please share your feedback and tips that you know about in the comments, and see you next time.